So in the previous video, we looked at taking these inverse trig functions and deriving them into functions of this form. Now we're going to be doing the opposite, the inverse, if you will, and we're going to be integrating functions of these forms into the inverse trig counterparts. Again, these are all on your formula sheet, so no need to memorize them, but we do need to know how to use them. So 3 simple ones over on the right-hand side to get started. The first one, we're going to recognize a few things. First of all, it's a positive numerator, or rather the entire function is positive. So it's not going to be cos, it's going to be this sine one here. And we're going to have some value squared minus x squared. So something squared minus x squared. So just to be clear, our a value is not 9. Our a value is going to be 3 because 3 squared is 9. So when we're going to be solving this one here, we're just going to be straight up transposing it and recognizing that if we have 3 squared minus x squared, that's going to be a squared minus x squared. So we're going to have x on 3, x on 3. So we're going to get I'm going the wrong direction. We're going to have arcsine of x on 3 plus our constant of integration. Simple as that. The next one here, it changes slightly because we have a negative one on the numerator. So this is going to integrate into the arccos function. And this here is going to not be 16 in our final answer. It's going to be 4 because of course 4 squared is 16. So this one's going to be arccos of x on 4 plus c, the constant of integration. And in this last one here, we're going to have, we're supposed to have a on a squared. So this one's almost set up to, well, this one is set up to trick us here because this is not a on a squared, right? A on a squared, this is a on a. So what we're going to have to do first of all is recognize that this 100 here is going to be 10 squared. So what we want is our a value to be 10. So the numerator here has to be 10. So what I'm going to first of all do is I'm going to say that's the same as factoring out a 10. So it's going to be 10 outside of the integral of, and now we can have 10 on the numerator plus x squared dx, because of course 10 times 10 would give us our 100, and now we're set up to turn this into our arctan function. So the solution here in red or pink is going to be 10 times arctan of x on 10 plus c. So those are a couple of literal, just substitute straight into the formula ones, and then one where we had to manipulate it slightly. Part of the battle with these types of questions is to recognize which trig function to use, or which inverse trig function to use, and also whether you need to manipulate it or not. Now, a more challenging question is down here, and we're going to go through this step by step because these are going to be the ones that you just need to think through a little bit and apply more steps to. These are going to be a complex, familiar type questions. This is going to be a lot of steps, and I'm going to do every single one very explicitly, but when you get fluent with these, you don't have to do every single step. Just keep in mind you can skip a few steps where possible and where you understand. So first things first, I'm looking at this, and as soon as I see some sort of fraction with a square root on the denominator, I'm thinking these rules, right? So that's an identification thing. I've got a subtraction down here and a square root, so it's going to be either sine or cos. The whole thing is positive, so it's not going to be cos, it's going to be this sine here. So I'm going to have to try and turn it into this form here. I can clearly see there's a 1 on the numerator, but I have a 5, so I'm going to rectify that immediately and change this into 5 outside of 1 on the square root of 16 minus 9x squared. So step 1's complete. I now have a 1 on the numerator. With that said, there's more steps to be had because in this expression here, I've only got x squared. I don't have like ax squared or bx squared or some constant out the front of x squared. So I'm going to have to manipulate this denominator to ensure that in my square root, I only have x squared. So the first thing I'm going to, well, not the first thing, I'm just going to continue on here. 5 times the integral of 1 on, and I'm going to be factorizing out within the square root. I'm going to be factorizing out of both terms the 9. So 9 is going to come outside of, and now 16, when I've taken 9 out, I need to make it 16 on 9, because of course, if I multiply this in, they cancel and I'm left with my 16. And now I'm going to have minus x squared. This is going to be a nicer one than you can get because the square root of 9 is a thing. It's 3. So I can just pull that outside the square root now. 1 over 3 times the square root of, and then what I had on the inside, 16 on 9 minus x squared. These are both dx, of course. So square root of 9 is 3, so that's come out. In my next line of working, I'm going to pull the 3 out underneath the 5 here. So I'm going to, let me just zoom out a little bit here. So I'm going to have 5 on 3 times the square root of 1 on, and as I mentioned, I'm going to be doing every single step. Just for this video, I wouldn't expect every single step in your assessments, but just keep that in mind. And finally, the last thing I need to recognize is that in my rule, similar to how I just had x squared, I've also got a squared. So I need to represent 16 over 9 as something squared. So essentially you just take the square root of 16 on 9, but within your square root. So it's going to stay in the square root, but get square rooted. It's a bit confusing, I know, but it's just something that as you practice, you'll get better at. The square root of 16 on 9 is 4 on 3. And by square rooting it, I'm now allowed to square it, which is good because it gets it in the form of something squared minus x squared. So now this 4 on 3 here is going to be my a value. And I'm ready to go now. This, what I've just set up, this final expression here, is going to be what I'm going to be integrating straight into the rule. So I have 1 over something squared minus x squared, 1 over something squared minus x squared, and it can go straight into this. X over a, it's going to be x over 4 on 3. So I might just bring this all the way up to the top. I'm going to have 5 over 3 out the front, times by arc sine of x on 4 on 3. Now that's a pretty ugly representation. So I'm going to be changing it ever so slightly to be arc sine of, now dividing by 4 on 3, which we've got here, divided by 4 on 3 is the same as multiplying by 3 on 4. So it's going to be 3x on 4. We've of course got our constant of integration, which I suppose should be on both lines. And there we have it. The integral of 5 on root 16 minus 9x squared is 5 on 3 arc sine of 3x on 4 plus c.